Let's talk about the stack and the heap, two important concepts for storing variables in the Java memory. The Java memory consists of different parts. Two of these parts are the stack and the heap memory. Understanding how this works will help a lot by truly understanding the difference between primitives and objects. Let's start with the stack. The stack holds the variables that are needed for running the program. Let's have a look at this example. We have a main method with an integer x, which is a primitive, and a value 5, and a boolean b, also a primitive, with the value true. These values are stored on the stack like this. First, we have the x, which is equal to 5, and it's of type int. And next, we have the boolean, which is of type boolean, called b, and it holds the value true. If another method gets called from within the main method, another record gets created in the stack. As you can see on the right of the screen, there's a new block, a record, for the method add that's being called from within the method main. And what happens in this case is that we have the add method, so we go ahead and we create a new record add. We send in 1 and 2 and we call them a and b, so it holds two values to start off with. A and b, both of type int, holding the values 1 and 2 respectively. And then in this method, something else is happening. C is being created, also of type int, and it holds the value of 3. Then it's going to return C, and after returning, the add method is done. And this is why the record on the stack disappears again, bringing us back to our main method. After that, the main method is done as well, and the stack is empty. The Java application can only access the memory of the current record the stack is on. That's why it's called the stack. As you can see, when it's in the method add, returning the C on that line, it can only access the variables that are on the stack in the add record. The main is not accessible at that point. This is just like a stack of plates. It can only access the top one. Admittedly, you could grab a plate from the middle, in the case of the actual plates. But let's agree, that's dangerous and wild behavior. So, what about the heap? Well, let's say that our method creates an object, for example, a string. Objects are bigger than primitives, and the stack is not designed to hold all these big objects. That's where the heap comes into play. The object gets created on the heap. And on the stack, we hold a pointer to the memory location on the heap. String is actually stored in a special way that we'll learn more about later. Instead, let's have a look at a person object that has a car object that has an engine object. Perhaps this is the data model of a car insurance company. If we create another object, we create another object on the heap and have the reference to this object live on the stack. If we create a car object in the main method and set it to be the car of the person, we add only one car on the heap. Both the stack and the person object point to the memory location of the car. Next, we create an engine and assign the engine to car. This is what the heap looks like then. There's only one engine that's being created, and both the stack and the car point to the very same object on the heap. If an object on the heap has primitive values, these are stored on the object on the heap. For example, an engine could have an HP. Likewise, as we have seen, if an object on the heap has other objects, the objects on the heap hold the reference to the other object on the heap. This is a very brief version of how the stack and the heap works. It's a lot more complicated in real life, but it's enough for now. Let's see what happens with primitives and objects when we pass them around.